So the official notes. So remember, regular is all sides and angles congruent. So we're going to just use a hexagon as an example, but if you were to draw a circle around your regular hexagon, okay, then from the center to a vertex of your polygon, okay, that is considered a radius, even a radius of your polygon, because if you look at it, it's from the center to where the circle would touch the polygon, right? Okay. So it is any of those would be considered a radius. Okay. And we've got our side length, which in your formula is going to be S. And then the reason they don't call this the height, we talked about this as the base and height of one triangle, which is, it's a lot easier to think of area in terms of your triangle and not the entire polygon. But the reason they don't call it that, the base and the height, is because this big figure is not a triangle, okay? And they need a different name. So from the center of the circle to perpendicular to any side is called the apothem. Okay. Now, again, to find the measure of, we'll draw another isosceles triangle. Let's call this one, just put a 1 in there. To find the measure of a central angle without the apothem in, okay. So measure of a central angle is 360 divided by the number of sides. Okay? Because since this is a circle, all the angles that meet at the center should add up to 360. So by dividing 360 by the number of sides, we get the measure of 1, which would be congruent to all the rest before the apothem is drawn in. Okay. Now, once you draw the apothem in, that splits this angle in half. All right. So one of the problems that they could give you is, you know, say you have an octagon. And with a lot of these, it's not going to be worth your time to draw the full shape, okay? You might want to draw enough so that you can figure out where the triangle is. For instance, decagon would be 10. Okay, so I'm not going to draw even the full octagon. Octagon, you do need to know, has 8 sides, right? So it is worthwhile to know the number of sides in your figure. But if I want to know what this central angle is, okay, so we're going to call this angle 1. And on this one, I'm going to draw the apothem in. And we're going to call this angle 2. And we'll call this base angle, angle 3. So you should be able to find any one of those angles. So to find angle 1, we would start by doing 360 divided by 8. Which should give you 45 for number 1. So the measure of angle 1 equals 45. The measure of angle 2 is half of that. Yeah. So the measure of angle 2 would be 45 degrees divided by 2. So 22.5 degrees. Yep, that's the 22.5. And how would you find angle 3? Nope, it's not half yet. Remember, you've got an isosceles triangle. This is the vertex angle, which was 45.
Aren't they all going to be 45?
Can that happen?
No. Yeah. No.
They could all be 60, but that's the smallest. I mean, equilateral triangle. They can't all be 45. That wouldn't be enough degrees, right? You would do 180 minus your vertex angle. So that'd be 135, yes. And then, of course, these have to be congruent. You divide 135 in half. So 135 divided by 2 would be what? 62. Is it 67? Yeah, 67.5 degrees.
What was that?
All right, so let's get down to the actual formula, okay? Now we kind of talked about it on the investigation. And again, I wouldn't worry about drawing the whole figure. That's going to be a waste of your time. I would draw in one triangle if they don't give you the picture. This is going to be the area of your regular polygon.
Irregular?
Regular.
Oh.
Okay, so we already talked about it in terms of a side and an apothem, and said we can find the area of one triangle and then multiply it by the number of sides, which is how many triangles we should have, right? That's how I would think of it. I'm going to give you both versions of that formula because if you go back to the book, they're not going to do it exactly that way. Okay, what they give you is 1/2 times the apothem times the perimeter.
Yeah, put in numbers.
Okay. Now what we talked about is we said, well, if you do 1/2 the base and height of your triangle, that is the apothem times the side, right? Times the number of triangles or sides. Okay. They just take the sides, the side length times the number of sides. That is the perimeter, right? So if they give you the perimeter, by all means, use the perimeter. But quite often we need the side length to find the apothem, you know.
So would you divide the perimeter by how many triangles there?
Yes. So if they give you the perimeter and you need a side length, you're just going to divide by how many sides you have. But what I'm telling you is you don't have to find the perimeter. If you have this information, I would find the area of your triangle and multiply it by the number of sides. That's really the most common sense formula and the one that I feel like if you understand how to find the area of a triangle, you should really have no problem with a polygon. Okay, so either one of these are, you know, they're pretty much the same thing. They're going to give you the same result. Okay, so we'll do a couple examples. We are going to do a decagon. With a 12.3 inch apothem and 8-inch sides. So in this case, you don't even really need to draw it out, but if you're all about the pictures and the sketches, I would draw one of your triangles, if that helps. Okay. Our apothem is 12.3. Our side length is 8. So your area should be 1/2 of 12.3 times 8. That's one of your triangles. And there should be how many of those in a decagon? Now, if you were using the formula with the perimeter would be 80, right? So this should end up being 492 square inches. Okay, now we'll actually do a couple of your homework problems. So 4 through 9 are pretty straightforward because they're giving you the apothem and side length. So you're just going to plug those in like we did here, and you've got your area. Okay. When you get to yes. When we get 10, 11, and 12, they give you a picture. We'll do 11. 10 and 12 are both hexagons, so you're going to find the central angle. Well, we'll do 10 and 11. Okay, so they give you a side length of 18, okay? So you're always going to want to start by getting your triangle, put in your apothem, okay? And we did the hexagon. Do you remember what these two angles should be? One central would be 60, right? So when you put, let's do it this way. So this would be 60. And if you don't remember how to do that, it's 360 divided by 6. So these two should each be 30, right? So if you put in your right angle, if a side length is 18, then what would this be?
18. Oh, the one side?
The one side.
9.
This would be 9.
And then there's 69.
Yeah. And that's a 60. So if that is your x, I know it's getting kind of small. If that's your x, remember what I said your height would be? That's your x radical 3. So if your x is 9, then your height should be
9 radical 3.
Yeah, 9 radical 3.
And then B.
So then your area would be 1/2
times 18 times 9.
times 18 times 9 radical 3. That's one of your triangles. And in a hexagon, there are 6 of them. Okay, and the rest is just simplifying. So you've got half of 18 is 9 times 9 is 81 times 6. Oh, and actually in this one, it does say round your answer to the nearest tenth, so you get to pop this all into your calculator. But if I were simplifying and keeping the radical, I would do 9 times 9 times 6, and then keep the radical. Okay, but that should be 841.8. Now this is one that you really want to pay attention to your directions, because they will say either round to the nearest tenth or keep your answer in simplest radical form. And depending on what that says, you either need to work around the radical or you can use your calculator. Okay, can I take this one away on top? All right, so 11 Okay, this one I'm going to show you differently because I just think it's silly. What they want you to do on your equilateral triangle is put the center in and draw the triangle and find the apothem and use the polygon formula. I think that's ridiculous that they would want you to do that, because this is an equilateral triangle, right? Which means every angle is 60 degrees. So if I just put in the height of my triangle, then I've got a 30, 60, 90. And we just did the 30, 60, 90. Your height of an equilateral would be half of your side length times radical 3, right? So this height should be 4 radical 3. And that's what you get in the hexagons. All those triangles in a hexagon are equilateral triangles, and when we put the apothem in, we get 30, 60, 90s. So you'd have half the side length times radical 3 for the height. So I would not, what they want you to draw in, and I wouldn't do it, they want you to put the center in and draw that triangle and the apothem. And if that's 8, that's 4. And they want you to mess with the other triangles that you get. I wouldn't do that. If it's an equilateral triangle, I would cut it in half and find the height, and then use 1/2 base times height of the big triangle. Okay. So the area for this would be 1/2 times 8 times 4 radical 3, and that's it. Because you're using the whole triangle, not drawing in extra triangles. Okay. All right. We'll do. What is it? Okay, we're going to do one with a radius. So we're going to do 16. And you don't have to do 16, but we're doing them anyways. It's a good idea for you to see what to do with the radius. Okay, so if they give you a radius, then what's true for all the radii? They'd all be 6 radical 3, right? Okay, the biggest thing to remember is if that's 6 radical 3, that is. Now we don't need the other one, but you're going to want to draw in both of them. Okay, and then that would be my apothem. So this is still a hexagon, so that little angle, which is half of the central angle, should be what?
30.
That should still be 30. So this would be x radical 3, and this time you are using the hypotenuse, right? This is 2x. So you have to go back to those ratios. They gave me the 2x. So if 2x equals 6 radical 3, then what is x?
3 radical 3?
Yeah, you divide out 2. So x would be 3 radical 3.
Is that 1? No.
Which is half of my side. Okay, so this would be 3 radical 3.
3 radical 3 radical?
So to get that, I'd plug into x. So this would be 3 radical 3 times radical 3, which would be 3 times 3, or 9. So my height is actually a nice number. That's just 9. And I need my entire base, right? Because that's my side of my triangle. So how do I double 3 radical 3? Just double the whole number, right? Or add 3 radical 3 plus 3 radical 3, which is 6 radical 3. Okay, so your area, so there's a little bit of work involved here to find the apothem and your side length. But then we have the area is 1/2, the apothem, which is 9, times the base, which is 6 radical 3. That's one triangle, and it's a hexagon, so that would be times 6. And this one, they want you to keep the radical in your answer. So half of 6, 3, 27 times 6 should be 162, is that right? 162 radical 3. So you could do 9 times 6 times 6 divided by 2. Yep, and then the radical 3 is attached because we didn't multiply by that. Okay, so that would be meters squared. Okay. I'm going to show you what they mean by consecutive radii. In 19 through 22, they say find the measures of the angles formed by 2 consecutive radii and a radius and a side. You're just finding the angle measures. So for 19, a pentagon, all you need to really draw out, okay, was one of the triangles. Well, actually, let's do 2. So I would do 2 of them. What they want you to find in 19 through 22, and you're only going to do 19 and 21 because I assigned odds, they want you to find the measure formed by 2 consecutive radii. So this would be A. They want you to find the measure of that angle and a radius and a side. So actually you don't need that one. B. So you're going to find the measure of angle A and the measure of angle B.
How many sides are in the pentagon? 3 or 5?
5. Okay. All right, so we do have